Okay, dear colleagues, we are starting the last day. So this is a day for the tutorial and for the question answers and some kind of exam. Yes, for this course. So the questions have already been prepared and discussed with me and Dr. Abhinav for the exam. So this would be online. So response you will get this list of the questions and then try to answer correctly, I hope. Yeah. Okay, so this is last study for me, and this is mainly was done by Dr. Dmitry Levshun. So he developed software for this tutorial. And the main content of the course. I just recommend some, maybe some improvement and how to, maybe some important issues, what to correct. So this is my colleague. Yeah, this from the my lab. Okay. And the idea of this tutorial is to try to practice with building attack graphs, but as this is not a real course in the study, but this is some invited short course, we a little bit shorten this because to work properly on all the phases of graph building, you need more time. So some maybe preliminary lectures and so this. And usually the technology and the approach how to build. So of course we have we need some input data. I mean, for example, we are working in the CM systems, and the task is to build attack graph. Maybe for the current attacks. So what kind of data we need? The first, of course, we need the data about network which we use, or the system which we use. Yeah. So this about the host, about the software, about connections, about protocols. So another this we need to know the vulnerabilities of the system. Yes, this is important. So what kind of action should be done by the malefactor to break our system and to have some actions on this, to get the information, some sensitive information, for example, or to destroy some software, or to maybe encrypt something. It depends from the what kind of attack we have seen. Yeah. And the idea of the software to build. So we have some open databases. I will show some kind of these databases. We need to upload these databases, and which these databases contain information about vulnerabilities. Yeah. And we have also this information about networks. So then we trying to maybe to find some point for the attackers to enter to the system, and then to have the chain of the actions using different vulnerabilities which are possible with existing software. So it will be some traces or paths of the attacks and what kind of vulnerabilities exist. But in this tutorial, we don't have this full cycle of all the actions which we need. We need some, we will see and we will try to practice with some of elements of this. So the first element, we need to upload the database and to do some actions with them and to see what is the content of this database. So usually this database called as a, so we have some feeds about this. So there's some information about the vulnerabilities. So you will try to upload this using Colab software. Then to see the content of these vulnerabilities, and you will try to see some of the vulnerabilities, because there's huge quantity of vulnerabilities, but to see, so there would be the links. You could see several vulnerabilities, and this is important to understand how they specified. Yes, what the main element for these vulnerabilities, what the element for the scoring of these vulnerabilities, which could be done. So this is important, and we try to practice with two interfaces. The first, we just locally will see these feeds and see these elements of these vulnerabilities which included in this file. And the second, this API. So this there is on the website of the company API, so you could use it. And the second task, which will be, we try to practice with ML a little bit, but for me it is important. So the minimal level, you couldn't know anything about the program languages, about Colab. I just tell you what to do. This is a minimal, yes. So this we could do that. Please do as I tell. Yeah, this. But of course, I know that you have some practice with Colab, and maybe you also know Python and some libraries for ML. So we will have some, of course, this is some short time, and you could play. So you could maybe use different models. So you just can point these methods from the scikit-learn. Maybe you know this library, and to change. So at first we will start with two simplest mechanisms for decision tree and express this decision tree. So, but the task which we try to solve, this is because we have several versions of the so-called SVSS systems which scoring the vulnerabilities. I will tell in the practice. So now there's some introduction that you understand the main idea and what to do. And the practicing will be the next hour for us. Yeah. But now I wait from you that you try to understand maybe the core of the theory for this process for the first hour. Okay, and the task is that we have several versions of the SVSS, and they are not, they are contradicted each other. So they have some intersection with vulnerabilities, and but they have different vulnerabilities also, not included in each of them. And the idea is to play with yes, and also they have different metrics for the scoring, and I will show this. And the idea is to maybe to try to transform from one kind of metric to another. I mean, from the one version of SVSS to another version of the SVSS. So anyway, this is a you could consider in the common technology for building attack graphs. This is some separate actions. Yes, and we just in this tutorial we will consider just them. But again, the main technology for building attack graph use a lot of steps. Again, this is, I just try to tell it slowly. The first, we should collect information. So the first is information about network, which we use. The second, information about vulnerabilities and their scores. Yeah. and then try to analyze this network. And the network means all the network, what kind of host, what kind of connection, what kind of protocols, what kind of software they use. Yeah, and the system. So we got this in database, and the system, AI system, should analyze them. And try to find the chains of the actions of the malefactor. And then usual visual analytics. We could see these ways, and also what kind of vulnerabilities have been applied for making these sequences of attack actions. But again, we just consider the first phase for the downloading and maybe analyzing the data about the vulnerabilities. And one of the phases, this is some maybe additional phase which I needed, that when we combined several vulnerabilities from different versions of the SVSS system. Understand this? Yeah? I try to very slowly to describe. So this is a main contents. And then again, depending, so using this task, we start to work with a collab. And the two tasks, the first is informative. You just see, then go to the link and to see this information about vulnerability, what kind of information on this, what kind of elements of this information we can have. And then try to play with maybe with different ML models. So the minimum is just use the constant that included in the text of the program. So this one. Okay. And again, what you need? You need the laptop. You need access to the internet for this. And maybe this is all. This, of course, it's necessary. Maybe there's some for the productive work. This knowledge of the Python or this working with Scala, and that, but this is not necessary. Okay, so I'm starting this tutorial. The content as follows. So we again repeat the information about attack sequences. Then we consider this knowledge base. This is, so there exists a lot of knowledge base about vulnerabilities, but this is one of the main, NVD. Then we consider other databases, and this is format for the vulnerabilities, SVE. And SVS and SPE. SVS, this is for scoring of vulnerabilities. SPE, this is for specification of platform. So they need to specify the software and hardware on the which are very needed, yes, for our task. Then we consider attack graphs. Then metrics for transformation from one version of SVS to another. And these two parts we will done together with you using this software which I explained. Okay? Ready to start? Okay, so this example from the previous lecture. This is because you know this. And so we have, again, maybe some infrastructure. And we have a lot of possibilities for malefactor to do attacks. So this is, of course, some usual network, but the same, and maybe if we win the project together, yeah, we will consider this problem for the automotive, yes, devices different, but the common approach the same. So we need to understand the structure, we need to understand the vulnerabilities, possible way of attacks, their consequences, how to then decide how to detect them, and how to detect efficiently, so the same. This is, I told you, this is for Olympic Games in Beijing. This is a real fragment of the infrastructure. And this is example of one of the attacks. So this is attack graph. And we have different sequences, possible sequences. Of course, attack graph, if we succeed, we go further. If not, we try to find another way how to penetrate the system. Mostly, of course, the proficient attackers do in the lab before intruding in the real system, and they mostly don't have these steps which are not going to the goal. So usually this is direct. This is because they play a lot of, they repeat the architecture of the system before. But this is professionals. So this is usually this is some hacker team, which well known. They play a lot. They develop their own software. They find some 0 days and use it. Okay, and of course this is example of description. We considered it on the previous lecture. And this is some specification of one of the vulnerabilities which we use. You will consider now, I'm planning that you will consider different vulnerabilities to see it and to see this specification. And usually description contains what kind of vulnerabilities, so what is a weak place in the system, how to do this, maybe the exploits, and some code, and what kind of software, hardware can be penetrated by this, yeah, using these vulnerabilities. Okay, so we will start this theoretical part. So for us it is important that, again, this is clear, we had several lectures, but for us, of course, it is interesting this to have some example of the open vulnerability database. So we consider this national vulnerability database, states, developed in states. So it contains a huge quantity of vulnerabilities in their specification, and they used the format, this common vulnerability and exposure format. You see that. The issue with it, that of course maybe not all the vulnerabilities are in this database. So if we try to use this database, usually we will have not the complete picture of the situation. Usually what to do? Different company they have this different addition for the vulnerabilities. Then different governmental agencies in different countries we have different. In Russia we have, for example, some federal services for this, and they have their own databases. So usually how they do, they include data from the open databases, transform them in internal format, and also they have their own vulnerabilities. So this is important. But for us, we accept this, that we work with the database. And also the problem with this database, this is that there are I talked about this. There are different versions for the scoring of this, and there are different, not completely the same. So this the reason how to use this metrics and to use for vulnerabilities, use the same metrics, which are completely with the same correspond with different version of the SVSS. Okay, and about attack graph construction using NVD. So the first, again, So we have maybe a CM system, we have a human operator, we have this database open. So we need to upload it, parsing it to the internal format, so to include it in database. Then, of course, we need to build the models of the attack. So this we need to, as I told, information about network vulnerabilities and actions of attackers. So, for example, for modeling, we could also imagine that what kind of attacker exists in our system. It could be novices, or it could be professional. It could have a local access, or it could be remote access. Local access, for example, if it could be that attacker's team have several people, and some of them are insiders also, or maybe some of the people included this remote software, which allow us to have a full access to the system. In this case, of course, we have also local access. Or also, it is important, maybe some of them have a physical access. So physical access, I could destroy the device, or get this some device from them, or change something, or include some hardware additional to change maybe some parameters of the system. And so this, of course, this is the highest level of possibility what to do with the system. And for the attack graph, of course, we need to know this attack graph as a set of nodes and connection between them. Also, what is the entry point to the system? And what is the exit point? Exit point, this means what we reach in the final state of the sequence of the actions. So we have a different attack paths, and we could calculate different attack path metrics. And we, of course, for us is very important to calculate the high risk attack path. So this what is definitely will be done by the malefactor, and maybe some other path, and metric calculation. So this is a common approach for building attack graph. So this is attack graph with some entry points. So this could be several entry points, some ways how to go from one host to another host, what is the risk for each of the way from one to another, and a lot of additional information for fulfilling the attack actions. Okay, this is understandable? Yeah. And SVE, so this we consider now this question, this SVE, SVSS, CPE. I already told about this, but in more detail. So SVE, common vulnerabilities and exposures. So this is a format for vulnerability description. You see here. This is some example. So we have a description, we have maybe this description severity, some SVSS in here into version. What is criticality of this base score, how this critical this system, and you will see today. We'll try to do this. Also, some, of course, the address of this database, you could use this and do it yourself. Of course, besides SVE, so we need this data about the common vulnerability scoring system, you see here. And also for us is important, there is so the database of common weakness enumeration, SWVE. So this is maybe vulnerabilities, not vulnerabilities in the same as some errors in the software which can be used, but this is weaknesses of the software and hardware which could be also used by the malefactor. About SVSS, so for SVSS we have a lot of metrics to calculate the integrated score. So they are maybe differentiated, you could see here, for three groups. So the first base matrix, the second temporal, and environmental. So this base matrix, this is the main matrix. So you see this CIA, yeah, this is important, and this is my first lecture about this. This is main. But of course, the first lecture I tell only these three properties, but there are huge quantity others. So this authenticity, privacy, and some other. But this is the main. And also this parameters for the attacks, vector, attacks complexity, privileges, user interaction, and the common scope of fulfillment of the attack. Temporal, they depends from the time and where this, so they could change, that could be added. And environment, it depends from the different environment where we implement. For example, if it is for automotive, for the cars, for example, or for the different system, for the cloud, maybe some kind of system. Okay, so this is some description in this for this, but I told about this. Okay, and this how to calculate. So we have this. So this is for example attack vector. Yes, you see this previous at IV. So the first two letters here the same for the temporal and environmental. And so we somehow there are the formulas how to combine them together and to have this. This is not important now for us. They have in description these formulas how to do. Usually they are defined heuristically. So there are no some laws of the physics for this, but they heuristically define what kind of influence of each of the parameters. And for SV, what is important? Yes, again, what I tell about. So SVSS has different versions. So this, for example, this the matrix for access complexity. This access complexity is very important matrix because they show what is the complexity of malfactor action can be done. So this for the version 2, this is a high, medium, and low. So this high, this very complex possibility. Low, this we don't need some special condition. So this novices can do these actions if the complexity actions. Okay, and for the for example 3.1. You see this difference. We have network adjacent local physical, but here this high, medium, low level. So this is discrepancy between using this. And now, of course, this is a recommendation what kind of SVSS to use. But the reason, for example, to build your own system which work with this, we need somehow to make some solution what kind of metrics and values of metrics we use. Yeah. And also we have a version 4, but mostly they just starting to include this information to the NVD about this. So we don't use it. So, but you, if you after parsing this feeds which you will get from the NVD database, you will see that some of them they include some information for the SVC 4, but they are not used yet. Okay, and again, this was for the complexity metrics, but this example for the user interaction. So some actions require non-user interaction, some of them passive, some of them active. So this is for the version 4. And SPE. So common platform enumeration. For us, it is also very important. This is because they specify the hardware and software. So what kind of, this is maybe formal specification. So what kind of maybe you see this vendor, product, version, some maybe update. So this information about this hardware, software, which important and which can have some vulnerability. So usually in description of vulnerability, we have this list of the hardware, software which are vulnerable. This is important. Okay, and this is some search result when we trying to find maybe some information. This example, and we found that, for example, here this search kind of vulnerability exists. And about the categorization. So this is stable. You see the difference between these two versions of SVSS. Here this red means that there are no such kind of parameters in this case. So this, for example, for version 2 we don't have the privileges required. And for the obtained privileges we don't have in SVSS version 3. And this is values and they are different. Okay. This is maybe our solution, but this is also some heuristical. So, for example, to implement in my CM system such kind of maybe this agreement about what kind of SVSS we use, we decided maybe that we consider some of the values which we use. So usually in the other system it could be others. Understand? Yeah, this one. So for us it is very important that we use scores for the vulnerability in uniform way. Yeah, in our system. So this is important. I don't go to detail, but this is important. And also this we try to have such kind of agreement about how to numerate parameters here. So the first is initial access right, then obtained access right, and then access vector. So this is important here when we build attack graphs. Understand? Yeah? So why we use this? So we have this action and we could depict it on the attack graphs. Again, this is our agreement, how to present. It is clear? Yeah? Okay. But maybe in another system it would be another. The question? Yeah?
Access rights, who gives this kind of accesses? Is it the administration or from the device configuration?
So maybe you missed the beginning of my this, because I told that we have different parameters to describe the actions, and we have for each vulnerability we have different parameter, for example, attack vector and access complexity, and we could characterize the actions of, for example, using vulnerability, such kind of parameters. Yeah, so they usually pointed by this on the specification of the vulnerability.
Yeah.
So we could go at the beginning. So this. For example, access complexity, yes?
Yeah, who is the person in charge for this kind of access? Is it from the network administrations or from the device configuration itself?
So this is from the point of view of attackers.
Okay.
So this attacker, what kind, if this action requires some the complex, yes, complex actions to do this, or this is a low. So you see this description. I missed it, but so for example, let's for the version 3.1. This is more interesting. So this for the network, the vulnerable component is bound to the network stack, and the set of possible attacker extend beyond the other option listed below. So this is this complexity. So the attacker can do the action from the external networks. And physical, the attack requires attacker physically touch the device. Yeah. Okay. Yes. So this is just numeration. Numeration accepted in our work. This is in the work of Dmitry Levshun. He suggested such kind of numeration, but it could be in others. So it depends from the solution of the developers of the system. Yeah. Okay, and we could select different states of the intruder, so attackers. So the same access vector and access right. For example, S1, it is access vector physical and access right none. And this is some fragment of the attack graphs. So this is some different maybe different transitions from one state to another, which are possible here. This, and for example, C11 physical required none, obtained none. So in this case, this is loop here, yeah, or this is loop from the C1 to C5. So this action go to this from the physical none to physical user access right. To now, then there are no access rights, but by the enlarging privileges, for example, doing some software and getting this usual privileges, so this we go to this state. Understand? Yeah. So for example, here we could work only as a guest in the system. Yeah. Here we can work as a user of here this we are the boss. Yeah. The boss. So this administrator which has all the rights. So this is different transitions from state to state. And also we could transitions from the, you see this network, adjacent, local, physical between them. And this is a complex picture of transition between. So if you remember the first slide of this tutorial, they're just very simple graph with just nodes and transitions. But here we see what kind of state, yes, we have. So this graph contained more information. And if in the CM system we see this, we understand, for example, from what state attacker go to the another state. And usually this kind of attacks depicted. Here we don't see the attacks, what kind of attack actions fulfilled. And also what is interesting is because the network contains, you see this, a lot of hosts and connection between them. Internally in the host there are a lot of software and hardware. So we have a graph internally in each host, graph of attacks. And the graphs which depict transitions around the network from one host to another. Yeah. So this is important, and different parameters can be. And maybe also this, if something already happened, we could some metrics if it was done, or maybe it was not done for false. So the attackers have not go from one state to another. Okay, and metrics transformation question. So this, again, this is some preparation for your activity with software. So we have two main these versions. So they described, so this is a quantity of vulnerabilities which described, and they are not intersected, but if we join it, so we, of course, in the system, we will have more vulnerabilities, so it would be a more complete picture of the vulnerabilities in the system. And our steps, which we are fulfilling, so this is, first we need to upload the system from the NVD to parse it, to store in the database. Of course, we need this JSON structures. You will play with that. Then we need to export the SVC metrics for each from the local database. So from these two, we have these files here, this approach. Then we will have these different features, and for the labels here, this just simply, and then we train the system, predict. So this idea so what we have done with ML so we will try this to do this training. So usually this is constant, this 5. You could change it to 3. So the cross-validation, I mean this. So you separate this for the 5 different sets, and some of them for training, some of them for the validation. So this would be done. And the idea, what kind of metrics, usual metrics for ML. So you will see this, the metrics for different ML approaches. I mean this accuracy, yes, F1 characteristic usual. So you will see, and then so you will see two metrics with decision tree and express decision tree again. But you could change this method for some others method. Of course, you can play also with parameters if it is if the time will allow us to do this, and it is also possible to change and to choose some methods from the scikit-learn library. Okay. So this we will have this final solution about this these parameters. And for the Dmitry Levshun, yes, he published paper about this. So he implemented several classical approaches, and he has you see some results about this. So, for example, for different metrics, for attack complexity, so what is the result for different metrics for the ML, what he have. And for some of them, he see that some, for example, for attack complexity here, this for access complexity, access vector to change. In some cases, he get pretty good results. Again, this is not our task. This is just I show this. We played with different methods and have do this. So also for the authentication, availability, and confidentiality, also this result. Some of them not very good, yeah. But this is usually, so we have this mean and the deviation, yes, you see in this. And for the others also. So this different result was in his paper. Okay, so this is some, again, some initial knowledge what we can do. Okay, now let's start. So do you have this presentation in your computers? I asked it to.
Yes, they have all the group, so they can
just upload this. Yes. Sorry, download this presentation, and we will start to work. This needed because you not fill the address manually, but just copy it. Yeah, this. Okay, just notify me that you have this presentation. Yeah, okay. So in the last year, Dmitry tried to do this, but he do this yourself, so on your computer. But now we experiment with the students how this would be done. So we will see the result maybe for the next studies. Maybe we got the knowledge. So you know this how the lecture work. So the first time this is some kind of experiment. what will be done and how to improve, yeah? Because now we try to with you. So this is good. This is interesting. What we'll see, and maybe the next, if we will have the next time, we will try to implement the full technology with attack graphs. Okay. Okay, just raise the hand who have the presentation. Some of them, we are wait. Do you have? Right hand, yes, I should know. So we could start, yeah? Okay. Okay, so this one, just go to this slide. Okay, so this, okay, the result, so we have seen the result of the different classifiers. So usually this is a good, because our course about using AI, so of course there are no exist the single, so yesterday was question, what is the best security method to apply? I told it there is no, so this it depends from the technology about the situation. Yes, so this we need to. So the same, we for example for here for the simple task for just for the transformation of the metrics, we have different results for different mechanisms. But this is again not demonstrative. This because we need maybe the. To see a lot of data sets, to play with them, so this is a very long process. But this is just maybe some initial results. Okay, so now we go to the practice side. And the first is work with NVD. Okay, so you could use you could this link or use this, yeah. So at first you need to create your own copy. So this. So to save the copy on the disk, this usual for collapse, yes, and register. You know how to do this. You work, yeah. To register in the system and to save the copy on the disk. So the first register. I will try to do this together with you now. So if you work this file, this menu, yeah, save copy on the disk. And the first we are working with approach work with NVD. So this the result is notebook copied, and
we have to click on that link approach one.
And you I will go to you. Yes. and then we go to the your copy of the. Is it okay?
You have to click on this link.
So you go to the file. You go to the save copy and the drive. Yes. Yes, and this open the new tab. Yeah. So you have your own copy. Yeah. Everything. Okay. No. You could, if somebody have done this, you could help the colleague. This, if you already work with Scalab, you should know this, yeah?
Yeah, just to copy it to drive on it.
Okay, so you need to go to to help. So let's write this. You need to go to the file. And you need save copy in drive. And so this is your own copy. So this is by this you doing your own copy of this. Only in this case you could work. Okay. So this. So now the next action. So we need to download the file. So this room, you see this. So I should comment this picture. Sorry, this because different speed from each user. Yeah? So you need to wait. Let's do it together at first. Okay, so you created your copy. Now this. So now you need to save copy collab to disk. You need to mount the also to mount the drive. You see this approach one here. So they work with NVD data, and this is a link to the NVD. You see, this is example. You see the schema version 1.1. So this is some parts of the vulnerabilities for different years, for different dates, and they could be in different formats. So this meta, JZ, and zip. Yes, we already have a link for the zip here. This so, and also you see the size of this. So you just list and go after this table. You see that. Let's work with SVE. So this is a version of SVE for this year, the current version of tutorial. And you need to download this file. So just knock into this link where this file, and then you have a new table in the browser for the for downloading. You try to download on your computer this. So I do it together with you. Just raise the hand if you have troubles with some. So this.
We have to download the modified file, right?
Yes. So if you download it yet?
No, I'm not downloaded. CV modified. That's it.
So let's list. Yes. List. I talk. Okay. You go to the. Sorry. You just need. So this is your copy. Yes, and this is just information. So again, this is the first link. This is information for the feeds, but you need to list this, and you see the file now. Yeah. So maybe I can show. Sorry. So you see this.
If you guys can all come here.
Again, you see this link, yeah? This file, yes? This link. This, of course, it's better to have my computer but this we spend a lot of time to do this now. So okay, this file you see, yes, you see. Sorry for, and then you just knock in this file and then try to save it on your computer. So again, yes, it's better to sit together. Yeah, it's better. So you could sit together and we don't spend a lot of time. So this is why important this practical work for my experience, because this is maybe a very simple action, but you need to understand that yes, that's this not very complex action, but you need to catch what is the lecture told. Yeah? Okay, so you again raise hand if you couldn't do this. For me, it is important that you do it yourself. This is important. So I think that you need to have the skill, yeah, to work with computer. Okay, so now this just unpack this file, yes, from the zip to the file. Do you have the software to unzip? So I'm doing the same. So you will see the JSON file after this, yeah? So this is a initial preparation for the work. Then we go again to this table in the browser. Okay, I go to this. And then you see this, the knocking the button, so the first string is from Google Colab import drive. You see this? Right after this, the name of this file. You see? So again, you see this file you copied, and this is, you see, so knocking this button, yeah?
It will mount that drive.
Yes, so we mount the drive. So it takes some time, yeah?
Maybe you can do one.
So you see this, this is in Russian, but you use this to switch to the Google disk.
Yes.
Yes, after this. So after this, you need to register if you have or choose your account.
I was saying maybe we can connect it on Google Meet and
Yes.
share the screen, and I'll connect that laptop. So it will
Yes, but I thought about this. Maybe this take time. This because usually I have some problems with. So you are not too much. So this, yeah. Okay, I will try. So register again. So it takes to load time. So now. Yes. So and after this you need to register. Yeah. So choose your account here, for example, and then continue. Okay, and again continue. So after this you are ready to work. Is everybody finalize? Maybe this is not a good thing as the first time. Yeah, this, of course, it is better to see this. Okay, everything is okay. So next, you just see step by step. You see the next. So this string from Google Colab import file. So try to do this.
Should I go to the JSON file?
So after this, you should choose the file.
The downloaded one.
Yes, this JSON file you should choose and open it. So it takes some time. So we will see this picture for the that this is last modified and the percentage of modified. You already done this, yeah? Okay. And after 100%, I will now check. You will give this, after saving this, you will have this structure of JSON. Okay, do you have a result? Yes, so now you need to analyze this file. So you see, you could help if somebody asks you. Analyze, and there are different links to the...
So maybe a short 5 minutes break for coffee.
Yes.
The coffee is here.
Yes.
And if you want, you guys can get it inside.
Let's interrupt and continue with this. Yeah.
It has links to the Red Hat community.
And then you can come with a texture on it.
Maybe also I have a Russian interface, so this also not good.
Yes.
Also,
plus,
before I need to, of course, switch to English.
Plus, for tutorial, it's important that they do it.
Yes.
So maybe I'll announce it. So let's have a quick coffee break. There is tea coffee outside.
Okay, let's
grab
interrupt and
something.
then continue.
Then we can start. If you want to finish it and come, up to you guys. Okay, take your time. Yes. So I'm initiating the closure part for the project, for this particular project. So there, I will be needing any boarding passes that you have for the journey completed so far. I presume you have the copy of.
Yes.
Sure. So please share that. If you have a hard copy, if you can share the hard copy, that will be helpful.
I have the here.
Okay, great. So
And
maybe after coffee we can.
also, I would like to discuss the next flight.
Yes.
Also, to buy this 5 kilograms.
That I will do that for you.
Yes,
No problem.
and the same maybe from the Surat to Delhi. Also,
Sure.
this two parts. Then it's okay for me.
I understand.
And for the money transfer, so
Yes.
I
So
could
have a
send
form.
you.
I will share the form with you now. You please
Yes.
fill all your details, including the transfer.
You
banking
will.
details.
Okay,
Yes.
okay. Yes.
So one is boarding pass, and please come. Tea or coffee?
Coffee.
Coffee.
So we will, after this, we will have this exam, yeah? After
We'll have a Q&A session, interactive some biscuit?
No, just.
Tea.
So we just try to ask the question, yes, them. But after this, we will have the exam, yeah?
Yes.
And the same for one hour or after?
I was thinking around 1 o'clock because some of them have classes.
So exam will be at 1
We
o'clock.
will do the exam at 1, between 1 to 2. Because there is
1 to
lunch time, so they are free for sure. They can attempt the exam.
Maybe to 2, from 2 to after the lunchtime.
No, I was hoping during the lunch because again they have classes from 2:30. So if I schedule from 2.
But it could be very quick, yeah, this.
Yeah,
I mean,
it's only 15 minutes exam. If you look at it, maybe 25 minutes or 30, not much. So I think they can finish it. Maybe it can start at 12:30 and continue till 2. So they have 1.5 hours. They can continue complete at leisure. Only thing is. Only thing is, I want them to attempt the exam at least to get the certificate. It shouldn't be that anybody who just.
But a certificate will be done
afterwards.
I mean, maybe next week.
Maybe
yeah.
2 weeks.
2
because
weeks,
I need a signature from
Okay.
the GYAN coordinator also and all.
Okay, so it just I am asking if I am involved in this process. So no, this you will.
So for certificate, maybe one option is I can create a template, and if it is okay with you, you can share a signature, which can be
Okay.
an image which I can paste
Okay,
there. It need not be your regular signature. It can be a I have one only for certificates, something of that sort. So.
Okay. Richard, so this is, you see the references to the different vulnerabilities. Let's see this.
This one?
Yes.
This is not allowing me to access it.
Authentication.
We are not authorized access back. Let's go. Let's do this. Maybe let's see it. Maybe some others. So this Mozilla, maybe this could see. So maybe this one. Yeah. So they close. Page not found. Vulnerability.
See if it opens up. My personal ID. Yeah, they have removed it.
But okay, I think let's scroll. You see this others, not GitHub, so you don't have the access yet. Maybe the others, some this Red Hat to see. So you see this. There are a lot of reference. So this is a feed. Include a lot information about a lot of different vulnerabilities which we have. And the first section we could see different vulnerabilities and their description, so specification. For example, this one, you see this this one on SVE. So this public from this January. So this is very new. I see. Yellow public on this is interesting. I don't see this. So we could get the information about such kind of vulnerabilities. So these vulnerabilities, you see this score, and the highest is a 10. So this 6.5, and the description. So just if you get this information in your computers, you could personally to investigate different different vulnerabilities and to see them. This is important for you to understand what kind of vulnerabilities, what is the element of these vulnerabilities. I give you maybe 3 or 4 minutes. Please see this. Yeah. And you could go to the link, then return again to the previous to see another vulnerability and to see these elements. So here you see these products which are vulnerable to this. For example, this Red Hat, yeah, this GBoss. So you remember this software GBoss was in the Olympic Games in the Beijing. And also you see this information about this different metrics for SVSS version 3, you see, for this. So again, we mean that we upload this information and we'll put to the database, which we then use in our research.
All these vulnerabilities have already been exploited.
Some of them, yes. So because how this is a cycle with vulnerabilities. For example, the company producer developed the software, and then somebody find this luck in this, and he report about this. But we have some lag or delay between this vulnerability and report.
And between that, if somebody
Yes, after report, if it is open, this after this, the company which producer try to implement some patch to do this, but this also requires some time. And if this equipment exists, so this vulnerability could be used, yes, by malefactor. So yeah. This is a lab, but again, some of them patched. But if you are administrator, you could miss it, and this software not patched. So of course it could be very old. For example, some of the people cannot buy it. This software they just copied with this bug, and he couldn't have the help from the company for the patches.
There is an open bounty also. No?
Yes.
People reporting any vulnerability, they get money for.
Yes. Yeah.
Open.
So this is why we have this. This is called this window for vulnerability. So, so this again for the big company. Usually they patched every patch, but they have this delay with patching. But the low company couldn't patch. So this always vulnerable. Okay, just see the other. Some of them, of course, yes, we need the access rights to see this, but mostly they are open.
That was the last one.
You see huge quantity of such kind of vulnerabilities. And you also could see this file and to see the main fields, what fields are used for this information in the database. So this is also important. Just choose some of vulnerability, the other vulnerability.
This one was the last one.
Your opinion.
The Red Hat was the last one.
The last one?
The Red Hat. The rest all were GitHub and Mozilla ones, so they were not opening.
But some other just listed.
This is what we opened, and the file just ends.
This because in my computer I can access this.
Oh, I don't know why I'm not able to access it. Which one? Mozilla. See, you can access it. Or the GitHub one as well.
Also is prohibited.
I think they have removed the access or removed the page also.
Okay, let's go further. You just scroll it and to see the next, yes, the next item for CV streaming input indicator. Let's do it. This one. Yeah.
Should I run it?
I mean this.
Yes, should I run it?
So you see this CV, the main fields, this data type CV. So this is a company which do this version, metadata about this, problem type, how to specify this, some references. So this link to the specification of this. Some configuration which I used and impact. Okay. So now we go here. Yes. So we could also use approach work with API. So let's go here just to see the instruction. It takes some time, of course. So just to be a specialist is not enough the theory, that you need to see this information to understand, to play with them. Let's see it. So this CV API, so what is it? So this is another way. So in this case, in the first case, we see this information locally and to see the structure of the file, JSON file, and to see the references. And this is special API interface, also can be used. You see this information how to, of course we don't have time, yes, to read it and to use. But for the future, you need to know this, and for the future, if you need to, maybe in some research or maybe your diploma, I don't see the topic connected with this. So of course you need to, after finalizing master program, yeah, what do you think about your future work, or maybe this PhD, yeah. But anyway, this additional information, and the goal of our course that you should know this, yeah, this security, and especially this is maybe this a little bit higher than usual course. Is because we give you information from the developers, as me, for example, yeah, and from the researchers, and from the other side, of course, we give you some basics of this, yeah, and some examples. Okay.
This CV API is basically to give a easy information on the total collection of the.
Yes, easy interface to see them, yeah. Easy interface.
So somebody doesn't have to go through the total.
Okay, as we have too little time, let's go to the second task to play with a little bit, maybe to start with ML. Yeah, so we just see it, and now go to the presentation.
The one which you said?
No, to the presentation slide. Yes, and we will use another link. So this we will consider that we try to play a little bit with this. We see this structure of the JSON site. So yes. So now we go next slide. So yes. So now we will see how to transform CSVC matrix. Yeah. Next. Okay. So this slide. So we also use Google Colab, but we tried simple ML classifiers for the transformation of some SVS metrics between this second and third versions. So what we will see? So again, we will download this input file, and we will play with these two models, simple models. So this model, this usual decision tree and extra decision tree. Let's go to this link. Okay, so this is a file. So this file describe. So this was preliminary pre-processed. So this is some categorical by these figures from 1 to 3 knowledge about this label and about this different metrics of. Let's scroll it below this. Okay, so this is a very large. You see this.
Should I open the Colab?
Okay, go to the Colab.
I believe. Is the repo private, this Colab repo? It's not
Is it
open.
open? Not open?
Is it still open?
No, it's open.
Is it open in your system?
There is a problem.
Is it open? It's not open. Are you opening the second slide?
Yes. How to transfer
So I also have access to you.
Okay. Let's shift to the personal area. We have to upload that data set. Retrieve that. Institute ID is being opened. You need to open it from the personal ID. The Insta ID. At the rate ID. It's opening on a personal ID, not the IIT one.
So let's do the same operation. So at first file, yes, and try to do the copy of the file.
I did the same thing.
Yes, and then try to
Yeah, upload it.
yes upload this file to. Then register. Yeah, yes. Yes, then mount drive. You could see we have too little time. We could see here. It's just so the same the same actions. Then choose the file which we uploaded this as an input file for the yes. So this structure for the pandas, you see this these two versions, different metrics which we use, and they use values from 0 to 3.
Where did you get that data set from? It is just a sample data set? Or it is a realistic?
Yes, we generated it. Yes. Yeah. So we, how we generated? We, if you remember my presentation, so we had some agreement about how to, yes, evaluate this, and we for all the metrics, we try to get this this table for different labels also.
In one of the slides, in the previous slides, you have mentioned about SIM, SIEM, software
CM?
software incident entry management.
Mm-hmm.
Yeah, so because every organization will have a SIM which is collecting data according to their organization specific.
Yeah.
So since it will be collecting all the data about all the events that is happening on the network, and we want to implement some AI or ML model onto that data, how should we get that realistic data set?
So it depends from the task. Of course, it could be some real data. It could be specially synthesized, because in this case, so this we had some developed some special software which generated this synthetically. Yeah.
A software to synthetically generate similar kind of data.
Yeah. Okay, so let's try to play, with it. So you need to go to fulfill each action, then data encoding. So one by one, all the actions. So this is some pre-processing feature instruction, and you see here. So this is you see. So from scikit-learn labor, we use these two classifiers. So also maybe for the if after this study you could see this, you see and okay, let's run this. Already done, yeah. Let's see the result. So you see, this is a result of this working. So this for these classifiers, this is a result of the usual metrics for ML, which we have. So, for example, for the accuracy, for the recall, for the F1 score, and what I'm planning, if you have time, maybe to play with different models. So again, this is a result using this model, but maybe the other model will have the better results. Yes, for this transition between this different version of SVSS. So this is, but now this our time. So in this case, we fulfill all the program, but in a minimum way. Yeah. So we just again seen two components which very important for the building the attack graphs. So the first component which needed to upload the feeds from the vulnerability database and parsing it, and also to have some knowledge about this, what kind of vulnerability we have. Maybe we unfortunately didn't have the access to some of them, but usually this allows us to maybe to be more knowledgeable in this area. And the second element, this is we should have this consonant system for the all the version of the system. So we accept some agreement what kind of metrics we use for this, and for the ML we try to see what is the quality of this using ML, of this transformation of these metrics for all the vulnerability we have. Okay, so this all. Thank you very much for helping me on this. So this is all. If you have questions, please ask me.
Except the comparison of different models that you showed, like DCNP, random forest, and another some 4 or 5 models. How much more AI or ML can be integrated into this cybersecurity?
So in this software, so you could use any model from the scikit-learn library. But of course, you also can play with parameters of the machine learning. Okay. Not so to use not initial parameters, but you could play with parameters and to see how it is better. But of course, you could employ some also combination of this mechanism. Using some voiding, for example, or baking, or some other mechanism for combination.
Can there be any prediction on the labeled data set that we will already have? Can there be any predictions using neural networks that if the network traffic is too high, there can be some type of attack, something like that of that sort?
Okay, so this is a goal of the software, yes, to do. So this, if you remember my previous lecture, for security analysis or for example for CM systems, so we have 3 main tasks. Yes, the first task to know previously what have been. So this information usually we call them historical data. They are important for future prognosis. The second, this is a current state of the attacking, and very important prognosis. So this we need to prognose maybe what kind of traits this first could be applied by malefactors. The second, we have maybe some action of the attackers, so we need to prognose the next action. Yes. So for example, in the February or March I will have the PhD exam and dissertation, so of my PhD. So the one of the topic is prognosis. So they prognose the next events in the sequence of events from the side of malefactor, which can be done. So in this case we use deep learning. So this yes, some combination of several deep neural networks. Okay. Any other questions?
So you can use deep learning and machine learning both, right?
Yes. Yes, machine learning, this is broader. Deep learning is.
But in most of the cases, which methods are used?
It depends, because the classical, they are simpler and less efforts. So in some cases they work better in some simple cases. So we also compare, but in the complex cases, of course, and when we have, for example, for supervised learning, when we have a lot of data for training, deep learning work better. This definitely.
What is the name of the software which generates synthetic data set for this kind of events, network data sets?
You ask me about what kind of data sets exist?
No, name of the software.
Name of software for?
synthetically generates the data sets?
Usually this is a complex task, and this is some proprietary tools. So for example, we generate our own tool. For example, we need to generate data for some of the infrastructure. One of the I think the sorts like my lecture.
Nowadays, for applying ML or realistic data or finding practical data set is itself is a problem. Finding data is itself is a problem on which models can be trained.
Yes. So what kind of approaches we have? The first, we have open data sets, which exist in the internet, and researchers developing them. And usually they are the result of some experiment with some equipment, with some network, and people use it. For example, in the 1999 and 2000, there was an experiment in DARPA, an American, and this was most spreading data set which I used. But this is very old. But what is good that everybody use it, and we could compare this different methods. So the first is open data set. The second we could ask the company. For example, for some mobile company, we have done some research, and we write an NDA for them. And they give us this data set, especially data set which was the result of work of many mobile users. And they was special by company, they was labeled somehow. And we use it for the company. But this is a very rare case, because for the researcher, we couldn't access such kind of data sets. So usually this is a property of the company, and this is confidential. The third way, we need to synthesize the data sets. So, for example, what kind of way to do this? The first, we try to repeat the infrastructure for which and try to really simulate the process in this infrastructure, and try to generate these data sets. Or other way, try to build some generator. So this generator which formally try to, in the case, for example, traffic, it can generate the traffic which we use for this synthesized data. But the drawbacks, this is not correct in many cases, because we don't take into account the real infrastructure of them. The other, we could give, for example, existing real-time data sets, but we could improve it, augmented data set. This is also very often used approach. So in this case, we need to play with them and add and to enlarge it somehow. For example, this is almost in every research we have this so-called problem with balancing of the different classes of, for example, attack. Some of the classes are majority classes, so there are a lot of examples. Some of the classes very low. And we need to use different methods, including this clustering method, k-means, and some others. There are huge of this also approaches. And we try to, for example, minimize the majority classes and enlarge the small classes for this somehow. But also the problem here that this is maybe for this augmentation we don't use the correct laws of the subject area. So it could be not correctly correspond to reality. Yes. So there are a lot of cases how to get this data. Also, there are cases when we try to use ML for the small data sets. Yes, so this is but also there are the drawback that we have also this so this problem that we have too little data for the training. Yeah. But this techniques can allow. But also we have a approach which called this Professor Abhinav told about this. That's about transfer learning. When we, for example, have these data sets from the area where we have this, and then we try to transfer to the area where we don't have or have a little data. But also the problems connected that maybe not all correspond to the new area. So
attributes may not be matching to the new area.
Yeah. So you see this, I listed a lot of approaches, how this data could be generated, how we could use synthesized data. But this is a theoretical, but of course it's very hard to build a good approach practically on how to do this. So this is a maybe this concrete case we need to. Okay, other questions? Okay, so this end yes of this tutorial. Many thanks for you. So this was the first try, yeah, and we will think how to improve this. Yes, thank you to you for helping for me, and we work together. Okay.
Sure, thank you. Maybe you can find thank you again, and I think if you still have any comments or queries, and you would like to proceed or stay around. For this particular course, this was the last session. So once again, my sincere thanks to Professor Igor for finding time for visiting us in person, for presenting these wonderful sessions. With a wide variety of coverage and depth, and also a hands-on session today. I think this was very helpful, hopefully for some of the folks who want to do research in this area or who want to apply this into their respective subject matter expertise as we go forward. I think that was very, very helpful. Plus, I sincerely hope some of you will start doing some work in this and reach out to Professor Igor, or you can connect with me and I can help you, coordinate and see if you can do some joint research, some exciting work as we go forward in terms of joint research, because that's primarily one of the reasons why we wanted to conduct this course in the first place. Do let us know if you have any feedback. So our plan is I'll be sharing the feedback forms. Please make sure you submit a signed copy of the feedback form. There is also this attendance sheet which you need to sign. Plus there is a quiz, a very short quiz, objective quiz that we are planning. I'll be sharing it now itself. I will keep it open for next 1 hour or so. So you'll have sufficient time to attempt the quiz, but do attempt the quiz. We will not be able to issue the certificates unless you complete all 3. So you must complete the feedback forms, share, sign, so that we'll be able to process the certificates. It takes a certain amount of time because once we have all the documents, we'll go for internal approval and all. So please bear with that, but we'll try to get back to you as soon as possible for the copy of the certificate. Once again, my sincere thanks to Professor Igor and for all of you for joining these sessions and making this course interesting course to attend. Thank you everybody. Thank you.